a refresh from yesterday of graphing linear inequalities. Remember, if you have a greater than or equal to or a less than or equal to, you're using a solid line. A dotted line is when you have a less than or a greater than. You shade above any greater than, and you shade below for any less than. Remember, it has to be in slope-intercept form in order for you to go ahead and graph it. So there's an inequality there, depending on what it is. So look at the equation I have here. Let's make sure it's graphed correctly. My slope is 1/2, because it looks like it's in proper slope-intercept form, so I'm able to identify. My y-intercept is -2. Be careful here. Did they cross the y-axis at -2? I don't think they did. I think they were down a little bit. Okay, so if I go up 1, right 2, up 1, right 2, up 1, right 2. So be very careful. Up 1, right 2. They were off a little bit. Down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. So they were off a teeny bit. So this part, they were correct in their shading though. All right, so I'm going to go ahead and use my calculator for those of you that are at home that didn't see me do this yesterday on a calculator. So I'm going to split my screen here. All right, and I'm going to use my Desmos graphing calculator. So go back. All right, and I'm going to graph this inequality to make sure it's correct. So you can put your y. Remember, if you use your little keyboard down here, I have a greater than or equal to 1 divided by 2. Go over to put the x, and then -2. All right, so did I do this correctly? My graph is counting by 1 on both axes, so that's perfect. It crosses at 0, -2 right here. So it looks like I did fix it correctly. Now, the 0.20, that 0.20 is right here. Is that a solution? It is, because it's in the shaded region. So this one is a solution. 5,1. Well, let's look at 5,1. 5,1 is right here. So would that be in the shaded area? It is, so it's a solution. -5, -4 is right here, so it's just on it, so that one would be an answer. -6, 7, so it looks like I need to roll around here. -6 and then up 7 would be right here, so that is a solution. So far all of them are solutions. 6, -2. 6, -2 is right here. That's in the white area, so that wouldn't be. 0, -1 is right there in the shaded, so that would be. So you can always check yourself on this Desmos as well. Okay, so everything except for E is an answer. This graph has a solid line because the symbol has an equal and or equal to sign underneath it. Okay, and remember, when it has a solid line, that means any point on the line is also a solution, would also make that inequality true. Why is the solution set shaded above the line? Why is it shaded above the line? Because all these ordered pairs in this area where it's shaded above the line make that inequality true. Okay, so all the ordered pairs above there make that inequality true. Also, these points above here are greater than or equal to, which again says the same thing. It makes your inequality true. So, because all points above line make inequality true. All right, number 2. Let's make sure this is graphed correctly. It looks to me like y is by itself, so it's ready. My slope is -1, make it a fraction. My y-intercept is -1. So I start at -1 on the y-axis. I go down 1, right 1, but this is counting by 2's. Okay, so just be cautious of that, but it's a less than, so it shades below. It's only a less than, so it's a dashed line. So let's go put it in our calculator also, so sometimes we can see it better there. So if I go to my calculator, type in y is less than, use your signs, negative x minus 1. All right, so let's check all these points. Negative 2, negative 8. So negative 2, negative 8 is right here. That's in the shaded area, so it would be an answer. What does that say? 8, negative 7? So 8, negative 7, 8, negative 7 is right here. That would not work. Negative 6, 2. Negative 6, 2 is in the shaded area. That would work. Negative 6, 7 is right up here in the non-shaded area. That wouldn't work. 6, negative 4. Oops. Here's 6. Here's negative 4. That one wouldn't work. And 0, negative 3 is right here, and that would work. All right, so this graph has a dotted line because the symbol is less than. There's no or equal to. Why is the solution set shaded below? Because the points below line make inequality true. Here's an important fact. If you have a solid line, points on the line will be a solution. If you have a dotted line, points on the line will not be a solution. Okay, so just be cautious of that. All right, so number 3, given the graphed inequality to the right, determine which ordered pairs are in the solution set. 0, 4 is right here. Is that in the solution set? It is not. 4, 0, would that be in the solution set? It would. Negative 1, 2 is right up there. That wouldn't work. 8, negative 3. That works. 0, negative 20 would be somewhere down here. And that would work if I could see more on my graph. Negative 6, 5. Doesn't work. 5, 5. 5, 5 is right there on the line. Does that work? It does because it's a dashed, or sorry, it does because it's a solid line. When it's a solid line, any point on the line works. 15, 4. So 15 is like over here somewhere, and then 4 is up here. Would that be in the shaded area? If I could see more of this graph, it certainly would. So all of those work. All right, I believe there is 4, 5, 6. So there's 3 more questions. I want y'all to finish those last 3 questions. Actually, I'll do number 4 with you really quick since I'm here. Determine whether the given point is a solution to the inequality. All you need to do is substitute the values. So I got an x value and a y value. Is that point going to make this inequality true? Well, the y value is 2. Is 2 less than negative 2 times x? The x value is 3. All right, so is 2 less than? Let's work this out. Do I do the multiplication or the addition first? Do the multiplication. So negative 2 times 3 is negative 6. Negative 6 plus 4 is negative 2. Is 2 less than negative 2? No, it is not. That is not true. So is this point a solution? No. It's only a solution if it makes that inequality true. We could also go and check ourselves. So let's go check really quick on our calculator. So let's type in negative 2x plus 4. I had everything else in there already. If I go look at the point 3, 2, 3, 2 is right here in the white area, and I can see that it doesn't work, which is why it did not work out when I tried it algebraically. All right, you try 5, 6, and 7, and then you're going to turn in a picture of your work.